Hello students, in this video we are going to discuss about the complexity analysis of algorithms. So in previous lectures we already discussed about the introduction of data structures and basic operations what we can perform on data structures. Here how can we analyze an algorithm whether it is efficient or not. So this will be discussed in this video. So here analysis of algorithms will do because we want to design an efficient algorithm. Efficient means in terms of time and storage. Less storage it needs to take the algorithm and less time it needs to execute that algorithm. Okay, so analysis of algorithm is is the determination of the amount of time, storage and other resources necessary to execute them. Okay, so that's why we analyze the algorithms. These analyzing algorithms also called asymptotic analysis. So asymptotic analysis evaluate the performance of an algorithm. So to evaluate the performance of an algorithm, we will analyze the algorithms in terms of storage, in terms of time. So that's why analysis is divided into two categories: time complexity and space complexity. Here mainly we will discuss about the time complexity, which is very important. So time complexity of an algorithm quantifies the amount of time taken by an algorithm. Okay. So how can we know how much time it will take? So by counting the executable steps, how many steps it will take to execute that particular algorithm. Okay, this will be categorized in three cases: worst case, average case and best case. These three cases will be, we will analyze how much amount in the worst scenario, how much amount it will take, how many steps it will take to execute this algorithm, and how many in average case, how many steps, and best case, how many steps. So this will be analyzed in this video. Okay, so these are the three cases: worst case, average and best case. So see here, worst case analysis, most of the algorithms we used to do worst analysis only. So here in this worst case analysis, so see, I'm talking about the linear search, the searching algorithm. Linear search means in linear array, if you want to search any element, that is called linear search. Okay, so this is the linear array. How many elements are there? 1, 2, 3, 4, 5, 6, 7 elements are there. Okay, so here I want to search the number for 8, whether 8 is available in this linear search. If 8 is available, it needs to give the output as in this particular location the 8 element is available. Okay, see here 8 is available here, no, it is not available. So but for us manually we know, but computer will need to search using the algorithm whether 8 is available or not. Okay, so worst case analysis, what happens, it will compare from the right from the starting from the 2. So it will compare with 8, no, it is not available. In 3 it is not available. In 5 it is not equal to 4, it is not equal to 8. 1, it is not equal to 8. At last it will give you, that is the 8 is not available. Okay, the 8 is not available. This is the worst case. That means if number is not available, it will search all the elements. That means how many times it will execute. Here in this array, it is having the 7 elements. It will take the 7 steps. Suppose in n elements are there, it will take the n steps. Okay, it will take the time to execute n steps. Okay, so for the best case, how much it will take? Suppose if you want to search for the number 2. Okay, so number 2, it is the first number only. Okay, if it is searching, this is the best case example. Okay, so number 2 means number 2 is available in the first location. So how many steps it will take? Only 1. Okay, it will take only 1. So this will be denoted with worst case order of big O notation. It will be order of 1. So in previous case, it will take order of n, that means order of 7. So here it will take only order of 1 because it is available in second. Suppose average case means it will take all the possible solutions. If it is in first number, the case will be 1 only. And if it is in last number, the complexity is order of n, order of 7. If it is in middle, it will take order of 3. All the possible solutions it will take, it will give you the average. So that is called the average. Okay. So here, most of the times we do worst case analysis. Okay. So the average case analysis is not easy to do in the most of practical cases, and it is rarely done because all the possible solutions we need to take first number में है तो what will happen, if it is in middle number what will happen, if it is in last number what will happen. So this is the this we need to analyze it. So this is the case of average. The best case analysis is bogus because always it will not at all possible. Always the number will be, we will get in a first number only. If you are searching, it is available in first number only. Okay, because it is very rarest condition. In 100 cases only one case will be possible, 1 or 2 cases will be possible, we can get the first case. Okay, first number only our wanted number. Okay, so that's why most of the times we do the worst case analysis of the algorithms. Okay, so this worst case analysis will be represented with big O notation. So this is is called asymptotic notation for the worst case, and omega notation is an asymptotic notation for the best case. It will be represented by omega, and it will be represented, the best case, average case will be represented with theta, and it will be for the average case, it will be represented for the average case. Okay, so here the best case, it will be replaced with the average case, omega for the best, big O notation for the worst, and theta for the average case. These are the 3 important notations which you are going to study the complete subject of analysis and design of algorithms. So in that you will study in detail way. Here in data structures, you only read the introduction about the worst case. Okay, about the asymptotic notations. So mainly algorithm will be classified into complexity wise, time complexity and space complexity. Here we are studying only time complexity. In time complexity, there will be 3 cases: worst case, best case, and average case. And best case will be denoted with omega, and worst case will be denoted with the big O, and average case will be denoted with theta notation. So these are the examples here. Find the worst case complexity for the following algorithm. This is the example of algorithm. So integer I, here I have given I is equal to 1. Okay, for finding the complexity, we need to identify how many executable steps are there. Okay, in this algorithm, example, this is not executable steps. This is only represents names. Okay, this bracket is for the open bracket. This is also not executable step. And this is the declaration. This is also not the executable step. Only it will allot the space for particular variable I. Okay, integer space, that means 2 bytes or 4 bytes, it will allocate the memory here. Okay, so here if you want to only executable steps means like complex statements, if statements, condition statements, control structure, that means for loops vagera, and these are all the executable steps here. So here this is the assignment statement, this is the executable step here. I is equal to 1. So here for the I, it is variable I, it is assigning the value of 1. So how many executable steps are there here? Only 1. So it is equal to how much the complexity is? Order of 1. Worst case only we are analyzing here. Only 1 step is the complexity. For particularly if you are executing this type of algorithm, only 1 step it will take. So, okay. So this is one example, a small example. Suppose example 2, here the loop is for I is equal to 1, I is less than or equal to n, and I plus plus. How many times it will execute this loop? Suppose here I am taking the 5. Okay, it will execute 5 times. Okay, the loop. Hai na? So if it is 6, it is 6. If it is 1000, it will execute 1000. So if it is generalizing, if you want to generalize it, so n times means it will execute n times. Okay, n here I have taken n value, we can define in the program. So if it is n, it will execute n times. So what is the complexity? Order of n is the complexity. Suppose in nested loops, it will take 2 times. It will execute 2 times. Suppose it is 5. Okay. Here I'm giving you the example here. Okay. In text, see. So what it is, suppose n is equal to, here I am taking the 5. Okay. In the first step it will take I is equal to 0 to 5. Okay. I is equal to 0 to and 5. That means how many times it will execute? 6 times. Okay. 6 times it will execute. But J loop, it is a nested loop. Nested loop means if I is equal to 0 and J will execute how many times? 0 to n. N here it is 5. So J will execute again 0 to 5, that is 6 times. Okay. Nested loop means for the particular 0 value, it will execute complete loop. Second loop will execute complete for the one step of the first loop. Okay. So for I is equal to 0, J will execute 6 times. Okay. So like that, if I is equal to 1 and J will execute again 6 times. Again, it will execute 6 times. So like this, so how many times it will execute? So if I is equal to 6, that is equal to 5, J will execute again 6 times. Okay, so how many times it is executed here? Total 6 times. 6 plus 6 plus 6 plus 6 plus 6. So it will execute 36 times. So it is 6 square times. Okay. So total worst complexity, we need to take highest number of times. Here J will execute highest number of times. So I will execute only 6 times, but J will execute up to 36 times. So we need to take worst complexity, that means highest number of times which complexity is more, we need to type. So J will execute, J is equal to 36 times it will execute. Okay. 36 times it will execute. N will be, I will be execute 6 times. So which complexity is more? J. So we need to take highest complexity. That means n square. That means n square times it will 6 square. That is equal to 36. 6 into 6. That is. So 36 times it will execute for nested. Suppose if you are having 3 loops, n cube. If it is having 4 loops, n to the power of 4. If it is having 5, n to the power of 5, it will take. Okay. So these many times it will execute algorithm. Okay. These many times it will execute if it is nested loop. So we need to increase the complexity here. Okay. We need to increase the complexity here. So here different types of complexities, order of 1, order of n square, n cube, n to the power of 4. And for while loops, we can get log n and n log n exponentially to the power of n. These type of different complexities, if we are analyzing more algorithms, we will get these type of complexities. These are the different complexities example. Okay. So here only I have given the introduction about the complexity. In deep, you will study in the 4th semester. Okay, so I hope you understand. So the recap is, what is complexity? Space and time complexity. Space means how much space it will take to store particular data in this algorithm, and how many steps it will take to execute the algorithm, that is called time complexity. Okay, for analyzing the time complexity, 3 cases are there: worst case, best case, and average case. Worst case means that highest number of times we will take. In most algorithms, we used to take worst case analysis only, and best case, average case, we will not consider in most cases. Rarely it will be considered. And worst case will be represented with the big O notation, and average case will be denoted with the theta notation, and best case will be denoted with omega notation. And here I have shown you different examples for calculating the algorithm. Okay, thank you, and I hope you understand this.